So previously in section 3.2, we were doing the multiplication rule. So the multiplication rule was telling us the probability of events happening one after another, so in a sequence. So now what we're going to be doing is the addition rule. The addition rule is going to be telling us the probability of at least one of the events occurring, which we use the notation probability of event A or B occurring. So before we get into this formula, I just have to define what it means to be mutually exclusive. So two events are mutually exclusive when they cannot occur at the same time. So if A and B are mutually exclusive, then the probability of A and B both happening is going to be 0 because they can't happen at the same time. So to kind of show this, I'm going to do a couple Venn diagrams here. So for this Venn diagram I'm going to make on the left, this is going to be when the events are mutually exclusive. If they're mutually exclusive, let's say this is event A and this is event B. So there is no overlap here, right? Meaning they cannot occur at the same time. Those circles do not overlap. So that means the probability of them happening together is going to be 0. When they are not mutually exclusive, let's say this is A, and let's say that this is B, there will be overlap. So there is overlap when they are not mutually exclusive, meaning they can occur at the same time. The place where they overlap here in the middle, this is what we refer to as the A and the B. So the overlap is the and portion. So for example, let's kind of make sure we understand this concept. For example, we roll a die once and obtain a 3 and a 4. So we want to know, are these events mutually exclusive? So when we roll a dice once, this is saying that we're going to get a 3 and a 4. So we have to think, can they happen at the same time? These outcomes cannot happen at the same time. So we say that these are mutually exclusive because they cannot occur at the same time. We cannot roll the dice once and get a 3 and a 4 at the same time. The next one, let's say we are selecting a jack and a face card from a deck of 52. We want to know if these events are mutually exclusive. So we choose one card. So we want to determine, can we at the same time select a jack and a face card from a deck of 52 when we're choosing one card? The answer is yes, because a jack is a face card. So face cards are jack, queens, and kings. A jack is a face card. So these can occur at the same time. So these are not mutually exclusive. Okay, so that brings us to our rule for this section here. Our little formula is the addition rule. So the probability that events A or B will occur, so at least one of them, either A occurs or B will occur, is the probability of A or B is going to equal the probability of event A happening by itself plus the probability of event B happening by itself minus the probability of event A and B both occurring at the same time. So that probability of A and B, that probably looks like the multiplication rule. So that's not the multiplication rule. It's just kind of an overlap of notation. This one that we're using here is the probability of A and B occurring at the same time. Multiplication rule is the probability of the events occurring in a sequence, one after another. Okay, and like we mentioned on the previous page, if A and B are mutually exclusive, then the probability of A and B happening together equals 0. So this formula would actually simplify to the probability of A or B equals the probability of A plus the probability of B. So let's see why this formula for the addition rule is the way it is. I put a little note down here and I'll explain it in a second. For this addition rule, we actually added in the probability of A and B twice, so that's why we're subtracting it off in the original addition rule. So let's see what I mean. So I'm going to create two little Venn diagrams. So the one on the left here is A or B, and the one on the right is A and B. So when we're looking for the probability of A or B, what that actually represents is this whole entire thing. It represents everything in A or in circle B. So when we're doing this probability formula with the addition rule, going back up here, so up here to the top, when we're adding the probability of A plus the probability of B, both of those circles have that middle portion. So we are adding that middle portion in there twice. A and B, here on the right, is the middle part. So we need to subtract one of those off because we added it in twice. So that's why in the formula it's the probability of A plus the probability of B minus the probability of A and B. We're subtracting one of those overlaps because we added it in with both A and the probability of B. Okay, so that is the addition rule. So let's do some examples. So we want the probability of selecting a 4 or an ace from a deck of 52 cards. So the giveaway here for what we're doing, that we know that we're doing the addition rule, is that or. So we want the probability of a 4 or an ace. So based on the formula, it's going to be the probability of a 4 plus the probability of an ace minus the probability of a 4 and an ace. Okay, so first one, probability of 4. The probability of choosing a 4, there are 4 4s, right? So it's going to be 4 out of 52, 52 total cards. The probability of selecting an ace, there are 4 aces, so that's also going to be 4 out of 52 for 52 cards. Minus the probability of a 4 and an ace. So we're choosing one card here. The probability of choosing a 4 and an ace, the probability of the card being both a 4 and an ace is 0. So a card cannot be both a 4 and an ace. So those are mutually exclusive events, which means the probability of 4 and ace is 0. So that term actually cancels off. So adding 4 over 52 plus 4 over 52, add the numerators, that's 8 over 52, which is about 0.154, or 15.4% chance of this happening. So the probability of selecting either a 4 or an ace is going to be 15.4%. Okay, so let's do the next one. So we roll a die. We want the probability of rolling a number less than 3 or rolling an odd number. So once again, we see the or, so we know it's the addition rule. So I'm just going to write these probabilities, the notation out here. So we want the probability that it's less than 3 or an odd. So based on the formula, this is going to be the probability that it's less than 3 plus the probability that it's odd minus the probability that it's less than 3 and odd. So doing one at a time here, the probability that it's less than 3. So we need to figure out how many numbers are less than 3 on a 6-sided die. 1 and 2 are both less than 3. So that's 2 out of 6. So I'm going to kind of draw it out here. Less than 3, that means we could have a 1 or 2. So next, for the probability that it's odd, the odd numbers between 1 and 6 are going to be 1, 3, and 5. So those are 3 numbers out of 6, so that's 3 out of 6. Minus the probability that it's less than 3 and odd. So we need every number less than 3 and odd. That's just going to be the number 1. So that's 1 out of 6. So that's going to be 2, 6 plus 3, 6 minus 1, 6. 2 plus 3 is 5 minus 1 is 4. So this is going to give us 4 out of 6, which is 2 out of 3, which is 0.6 repeating. I'll just put 0.667, or 66.7%. So 66.7% chance of that happening. Okay, next one here. We want the probability of selecting a 10 or a diamond from a deck of 52 cards. So we see the or, we know it's addition rule. So it's going to be the probability of a 10 or a diamond. So I'm just going to use a D. Probability of 10 or a diamond equals the probability of a 10 plus the probability that it's a diamond minus the probability that it's a 10 and a diamond. So the probability that it's a 10, there are 4 10s, right? 4 10s out of 52 cards. Plus the probability that it's a diamond. A diamond is a suit. There's 13 diamonds, so 13 out of 52. Minus the probability that is a 10 and a diamond. There is one card that it's a 10 and a diamond, and that's the 10 of diamonds. So 1 out of 52. So 4 plus 13, 17 minus 1 is 16. That's 16 out of 52. Which is 4 out of 13 if you wanted to simplify it. Or 0.308 as a decimal. Or 30.8% as a percentage. So a 30.8% chance that it is a 10 or a diamond. Let's do a couple more here. So suppose you roll a die. What's the probability of rolling a number greater than 4 or rolling an even number? So we see or, so we know it's going to be addition rule. So probability of rolling a number greater than 4 or an even number. It's going to be the probability that it's greater than 4 plus the probability that it's even minus the probability that it's greater than 4 and even. Okay, so this is going to be, we want the probability that it's greater than 4. The probability that it's greater than 4, that means it can either be a 5 or a 6, so that happens twice. So that's 2 out of 6. The probability that it's even, there are 3 even numbers, 2, 4, and 6, between 1 and 6, so that's 3 out of 6. Minus the probability that it's greater than 4 and even. There is one number that's greater than 4 and even, that's 6, so that happens once out of 6. So kind of a little hint here for these, the denominator should always be the same because it's the same sample space. So 2 plus 3 is 5, minus 1 is 4, so that's 4 out of 6. Or 0.6 repeating, or 0.667, or 66.7%. Okay, let's do one more of these ones, then we'll move on to the last thing here for this section. Suppose you roll a die. What's the probability of rolling a number greater than 5 or less than 2? So we need to set up this formula. And we get this setup, probability that it's greater than 5 or less than 2. It's the probability that it's greater than 5, plus the probability that it's less than 2, minus the probability that it's greater than 5 and less than 2. So the probability that it's greater than 5, there is one number greater than 5 on a 6-sided die. It's 6. So that's a 1 out of 6 chance. Plus the probability that it's less than 2. There's one number less than 2. That would be 1. So that's going to be a 1 out of 6 chance. These are mutually exclusive, right? We can't have a number be greater than 5 and less than 2. So that last portion is going to be 0. There's no overlap, so there's nothing we need to subtract. So 1/6 plus 1/6 is 2/6, which is 1/3, which is 0.33333, repeating, or 33.3%. So essentially what this question is asking is, what's the probability of rolling a 1 or a 6? So moving on to the last type of question here. So it's a little bit different, but it's going to be conceptually the same. So suppose we have this following table here, and it represents the amount of blood donors at a hospital. So we see this blood type. So we have blood O, A, B, and then we have the total. And then we have whether or not it is positive, negative, and then we also have that total. Okay, so let's do this example here. So let's say if we randomly select a donor, find the probability that the donor has type O blood or type A blood. So this is going to be the addition rule. So we're looking for the probability that it's type O or type A, which is going to equal the probability that it's O plus the probability that it's A minus the probability that they're type O and type A. So type O, where's type O at? So here's type O. Here's the total for type O. It's 184. So it's 184 divided by 409, because that is the total amount of donors. So 409 is the total amount of donors. So the probability that we randomly select a person with type O blood is 184 divided by 409. Plus the probability type A. The probability of type A is going to be the total for A over the total number of donors. So it's going to be 164 over 409 minus the probability that they're both O and A. The probability that they're both O and A, they can't be both O and A, so they're mutually exclusive. So that means that last term is going to be 0. So we don't need to add anything to it. So we're going to add those numerators, and we're going to get 348 divided by 409. And as a decimal, this is going to be about 0.851 or 85.1%. So 85.1% chance that they're either type O or type A. Okay, so let's do another one. Let's do if we randomly select a donor, find the probability that the donor has type B blood or the blood type is negative. So let's set up this formula. It's going to be probability that it's B or negative equals the probability that it's B plus the probability that it's negative minus the probability that it's B and negative. So for the probability that it's type B, let's go back up here. Type B is going to be, there's 45 total B, type B blood out of 409. So that's going to be 45 over 409 for type B. Next, for the negative, that's going to be the row this time. So the total in that row for negative is going to be 65 divided by 409. So plus 65 over 409 minus that they're type B and negative. So type B and negative just means B negative, which is 8. So we see where they intersect each other on the table. So it's 8 over that 409. So we add those first two and subtract the 8. We're going to get 102 out of 409, which is about 0.249, which is 24.9%. So there is a 24.9% chance that we select a donor and they have either B or negative blood type. Okay, so that's it for 3.3. That is the addition rule.